Here today's lesson with Uncle Keev's on cubic measurement. Cubic measure. This is when we start to move from two-dimensional to three-dimensional. So if we've got a 1 metre by a metre by a metre box, that there is equal to 1 metre cubed. Now you see there it's got a 3, meaning 3 measurements. Here's the formula here. It's going to have a height multiplied by the width multiplied by the length. Alright, so height by width by length, 3 dimension, 3 metre cubed. Why do we need to know this? Which is always a good point. Mainly for our concrete floors and subfloors, excavations, how much concrete we need, even if we're boxing the path outside, how much concrete for the path. Some of our contractors, like our excavator operators, they'll have a conversion chart. So we might work out how much hard fill we need underneath this house, and then tell them we need 20 cubic metres, and then they'll convert that, because I think there's about 1.2 tonne, because they're talking tonne, so 1.2 tonne per cubic metre, so they can work out how many 10-tonne trucks they need to bring our hard fill. Alright, so we need to be able to work out our volume in a metre cubic metres. An example here, like even if we said about the path, if we had a concrete path that was 100 mil thick, 100 mils good thickness for a concrete path. If it was 10 metres long, you could divide that up into 10, sit them all on top of each other, and you'll end up with our metre cubed, because 0.1 times 10 times a metre equals 1 metre cubed. And an average house, if an average house is about 180 square metres, looking down in plain view, times 100 mil thick, then you're going to have 18 cubic metres of concrete to do that floor. Alright, we'll do an example just to get you thinking about it. Righto, formula, height times width times length. If we had a shape like this here, so it was like a column, a beam, a nice long beam, and it's 10 metres long, 0.8 of a metre wide, 0.45 of a metre high. That's what we've been given. We've got to work out how much concrete we need for that. So it'll be height 0.450 times width 0.8 times the length equals. So if we do that, 0.45 times 0.800 times 10 equals 3.6, and then we have to have our metres cubed. So that particular shape there, 3.6 cubic metres of concrete will fill that. Now if we have something more in the shape of a column, keep that same formula. The column will be that shape, and it might be 0.45 square, 0.45 square, and 3.2 metres in height. That could be our column, so we use the same formula, 0.450 times the width, 0.450 times the height of 3.2. Here we've got 0.450 times 0.450 times 3.2 equals 6.48. 0.48 metres cubed. Now, if we did get to a stage like that and we had 0.48, that's really going to be, you round it up. So you'd round up, when you get on the dog and bone and ring up, so you'd make that 6.5 metres is what you'd order. So you'd round that up from 6.48, and 6.5 would be the amount you order, because you can get your concrete in multiples of 0.1, so you can't get the fractions. Alright, so formula, height times width times length, cubic metres, 3 dimensions, that's that. Alright, thank you. Now the second part to this volume, cubic measurement, is going to be a cylinder being round. Now you'd have that as a pile underneath your foundation, or as a column if you're holding up some beams in a commercial job, but you're going to have a cylinder. So we need to know how much concrete's involved in the cylinder. So say our cylinder's 1200 of width and diameter and 2.6 metres in depth, and we have to work out how much concrete's involved there. We get the formula. Now our formula is pi times radius squared times our length. Right, equals volume. And it'll be in metres cubed. Metres cubed. And now if we check out with these numbers, well, we start by unpackaging this here. And what have we got? Pi. What's pi? Pi was done by a Greek mathematician called Archimedes, and he was around in about 200 BC, which is a long time ago. And he worked out, when you're working out the surface area of a circle, 22/7 was his magical pi measurement, and that equates in fractions to 3.141592654, which is plenty of digits there. So that's our pi. Our radius squared, if we unpackage that, what's our radius squared? We know we've got 1200 in diameter, so if we write that down there, radius is equal to half the diameter. Right, so if our diameter is 1200, in this particular case our radius will be half of 1200, which is equal to 0.6 of a metre. So there's our radius, there's our length, there's our formula, so we can go ahead and we can work out how much concrete's involved in this cylinder. So we punch into our computer or our calculator pi times 0.6 squared times our length, 2.6, equals. There we go. Now, fortunately, I've got a shift. Pi times 0.6 squared times 2.6 equals 2.9405 metres, cubic metres. Now there's your answer. That's exact science, and the concrete plants don't do exact. So at 2.94 you would round that up, and you'd round it up to 3 metres of cubic metres of concrete, and that will give you just a couple of barrelful left over, which will be just fine. Alright, so we've got a formula, pi r squared. Now if you get asked to do one of these in an exercise or in an assignment, then the formulas will be given, so we don't have to remember that. We just need to remember how to apply it. So we'll have our formula, our radius and our length, and then we'll come out with our answer. Alright, well done. The last part of cubic measurement with Uncle Kev is going to be when you see a footing and a foundation and you have to add them up. So it's not a lot different, but we've got to work it out in two different squares and then add them up, get them into that good shape. So we're still going to have our formula, height times width times length equals volume, and our answer is going to be in cubic metres. Cubic metres 3,123, and if we get off the plan, if we can see a cross section of our footing here and our concrete foundation wall there, we might have 0.4 of a metre there, 0.2 of a metre there, 0.750 of a metre there, and 0.15 of a metre there. If that's what our cross section is, and then the perimeter around the building, we've done perimeter before. Perimeter is 20 metres. And then this will be our formula. Height, to do our footing first, height's going to be 0.2 times our width, 0.4 times our length, 20 metres, equals 0.2 times 0.4 times 20 equals 1.6 metres cubed. Then we do our foundation here, same deal, height 0.750 times width 0.150 times our length will be the same, 20 metres our perimeter, and that there equals 0.75 times 0.15 times 20, 2.25 metres cubed. We add them up, we're going to have 5, 8, 3, 3.85 metres cubed, in which case you'd probably round that up and order 4 metres. Alright, that's how much concrete it will be. So the simple thing we did there was we divided it into 2 bits. So we did our footing first, then we did our foundation wall, and then we brought them both together on this bit here. Alright.